So I've got this area problem still. Find the area beneath the graph of some function, but above the x-axis. And I've said that I only care about x values between, well, for right now, 0 and looks like a equals 5. But for this parabola, I don't get a nice geometric shape. Once again, I would like to make this problem easier. Now, at some point, there's only so much we can do with an easier problem, and we will have to get back to doing the hard stuff. But what if I could turn this problem into something easier, right? What if I could change this into any geometric shape I want? Well, what are the easy shapes for finding area? Circles, triangles, polygons, maybe? Like if you're walking down a dark alley and somebody pops out, shows you this picture. They say, tell me the area of this. They got a gun. You'll be like, well, let's get started. But someone did the same thing, pulled a gun on you in a dark, deserted alley, and they said, what's the area of a rectangle? You'd be x times y, please, x times y. Very simple. So what we are going to do is, let's look at rectangles. So I would like to find this area in red. And maybe I can fill in with rectangles. Now, what rectangles am I going to use? Well, these rectangles are actually covering up too much. Maybe I want some rectangles like this, maybe, but that'd be not enough. Anyway, let's have the computer draw these for me. So here are some rectangles. Each of them, Desmos has not drawn in the sides here for me, but each of them is exactly 1 unit wide. Each of them has height that exactly touches that curve. So I can find this amount of area very easily. I just need to know base times height for every single one. And in fact, every single base here is just 1. So my first height is 1. So I'd have 1 times 1. My second height is 2. My third height is 5, and so on. So my area should look a little bit like this. Rectangle of height 2, rectangle of height 5, rectangle of height 10, rectangle of height 17. And I would want to see what I get from this estimate. I already know from the picture it's not going to be exactly the right value. But here I get about 35. So however much area is in red, there's going to be at least 35 units of area there. Maybe I could change my formula to tell me an upper bound as well. So rather than floor of x. How about out of floor of x plus 1? Now these rectangles are covering up too much. So I know that there are more than 35 units in area for this figure. For an upper bound, again, I just need to know the heights of all of these points. And in fact, it's mostly the same numbers as before. That's kind of funny. So 2, 3, 2, 5, 10, 17, and what was that last one? 26. Okay, 2, 5, 10, 17, 26. And I'm going to add them all up to get my estimate. I get 60. So in red, there are more than 35 units of area, but less than 60 units of area. I don't know about you, but I'm not sure that this helps, right? There's a lot of wiggle room between 35 units of area and 60 units of area. Let's tidy up.